So here is a very good example of how we're going to be testing a single sample value. The question goes like this: a normal population has mean 30 and variance 16. It is claimed that the sample value 35 comes from the population. We need to test at 5% level of significance whether this claim is justified. Now, first of all, I'm going to let x equal the observations, okay, coming from a population with mean mu and standard deviation standard deviation mean 30, so standard deviation is 16. 16, which is 4, because the square root of the variance is the standard deviation. Okay, so now we have x normally distributed with mean mu and standard deviation 4, which is basically the variance is 16. Now, what is our null hypothesis? In this case, we have a null hypothesis, which is basically HO, such that the mean mu is now 30. And we have also the alternative hypothesis, where H1 mean mu is not equal to 30, because we need to find that the sample value 35 is it coming from this population, or is it not coming from this population? So whether or not it's coming or not, all right, so that's going to be then not equal to 30. So, and the thing that we do when we have this is we need to carry out our test statistic Z. So the test statistic Z, which is the sample value, sample mean, which is now 35, minus the mean mu 30 over the standard deviation, square root of 16, and all of that's going to give you 1.25. Now this is our Z value from the test statistic. And because we're now testing at 5% level of significance, so our normal distribution curve will go like this. It's a two-tailed situation, and we did say it's a two-tailed situation. Why? Because it's either 35 or not 35. So this is where our acceptance region is going to be. That's the alternative hypothesis, which is H1. And here we have 5% divided by 2, so this is 2.5%. And we also have 2.5% over here. And so we need to find this and this, the Z value, all right, of our significance level. And therefore we do it like this. So this is Z and this is Z. And so we have basically minus Z. So I'm going to say then 1 minus the phi of Z is equal to 2.5%, which is 0.025. So Z is going to be equal to the inverse of 0.975. And how we do this, 1 minus 0.025. So I got Z as plus or minus 1.96. So this is now 1.96 negative, and this is positive 1.96. And since x is equal to 35 and that Z is equal to 1.25, since x equal to 35 and Z is 1.25, the 1.25 basically now falls into this region here. If it falls in this region, we accept HO. So we're saying that this value 35 comes from the population. So what we're saying then is that therefore it is concluded that the sample value x is equal to 35 comes from the population. Why? Because this 1.25 falls within the acceptance region. Remember, this is the acceptance region. If it was in the rejection region, let's say it was greater than 1.96, let's say 1.97, it would have fallen into the shaded region. This is our rejection region. Then we would have we would have rejected the second one, this one here. Or I mean, we would have, it didn't fall in the rejection region. All right, we would have rejected HO, I mean, if it was in the rejection region. Also known as the critical region. So here we are, this is our solution for this problem, and I hope you've been able to understand. Thank you for your attention.